Hi everyone, I am Shubham and I'm a researcher here at IIIT Bangalore. I'll be handling the open source technology lab. I'm a researcher over there. So today we'll be talking about the Kubernetes, how it simplifies your container orchestration and how it can simplify your life. So, starting with the biggest question of the day, what is Kubernetes? Well, it's known for its K8s cube, and here's an interesting fact. The number of characters between K to S is 8s. That's why it is usually known as K8s. So, we do know that Kubernetes is an open source orchestration system for the containers. But what does this actually mean? Well, with Kubernetes, you can automate your application deployment, scale the size of your application, and manage the containers. It can scale your application without increasing your ops team. So that is the plus point with Kubernetes. Coming to the next question, what does Kubernetes do? Well, mostly, the popularly known as Linux kernel of the distributed system. And the biggest thing with Kubernetes is it abstracts away the underlying hardware of the nodes and provides a uniform interface for the workloads to consume the shared pool of resources, the pool resources we have in the clusters. Now these can be used by every other node using Kubernetes. So the biggest question today is, how is it different from Docker? Um, I usually don't compare Kubernetes with Docker, but you can always say if Docker is an apple, then Kubernetes is an apple pie. So with Docker, it lets you put everything you need to run your application into a lightweight, portable, self-sufficient box called container that can be stored and opened when and where it is required. Once you start boxing up your application, you need a way to manage them, and that's when Kubernetes come into the picture. So hope you get that, like how Kubernetes is compared to Docker. But there's one more thing. I always say, if Docker is a container of the ship, the Kubernetes is the captain of that ship. So, and that's what it exactly means. The Kubernetes is a Greek word which means captain in English. So yes, with Kubernetes with Docker, they work well hand in hand. You can build, deliver, and scale up your containerized applications. Kubernetes does have a lot of features, and these features will definitely be seen in our demo today. We'll be seeing about automated rollouts and rollbacks, service discovery and load balancing, storage orchestration, secret and configuration management, horizontal scaling, and self-healing. If a particular node dies, it will reconfigure the node and up the node without making any changes to your configuration. Now coming to how Kubernetes work, we have a master node, we have a worker node, and all these applications are called pods in your system. You know, these are running in your worker node, and here you can see the pods are in your cluster. And so where do we come into the picture here at master? So we are scaling up our application, deploying new rollouts, new features, and the master takes care of it. But along with this, master and worker node does have a Kubernetes components. We have control plane, often known as the master. We have nodes, often known as the worker nodes. So these do have a lot of architecture. Let's dig a bit in the Kubernetes components. In the master component, we see we have a kube API server. Well, it exposes the Kubernetes API. The API server is the front end of the Kubernetes control plane. Now, coming to the etcd, in the master component, it is a distributed, consistent key value store used for configuration management, service discovery, and coordinating distributed work. The scheduler over here means it watches for newly created pods, your newly created applications. So if it is not assigned to a particular node, the scheduler will do it for you. Then we have controller manager. The controller manager, it manages all your core components and makes the necessary changes, attempting to move the current state towards the desired state. And all these things, make up for a control plane, the master node. Coming to the node components, over here, we have kubelet and kproxy. Well, with the kubelet, it is responsible for running your application and reports the status of the node to API server in master node. Coming to the kube-proxy, it runs on each node and responsible for watching the API server in the master node, and it maintains the entire network configuration. Also looks for any changes. If there any changes occurs in your worker node, it will inform the API server in master node. So without wasting much time, I'll simply dip to my demonstration, and the demonstration will be presented using Minikube. Minikube is a single node Kubernetes cluster locally for the purpose of development and testing. You cannot use Minikube in your production. For that, we have various other things. We have Google Kubernetes engine and AWS. Azure also provides the Kubernetes engine. So yep, we'll be looking in one such application where we'll be having the deployment, the pods. A PVC will come into it, what exactly all these things mean. And also we'll be having an ingress. Ingress is responsible for handling your traffic from outside world, from your outside internet to our cluster. So I'll just share my screen. So over here, I've already started my Minikube because it takes usually a ton of time. So before the session, I only just started it. Along with that, I also opened the Minikube dashboard. So we'll just look into the dashboard first. Yep, over here we have the Minikube dashboard. So we have workloads. Within the workloads, I did show you like we had our deployments, the pods, and the replicate services. I'll come like what does it mean and everything. So the deployments we did, I did create 3 deployments: the server deployment, MySQL deployment, and the client deployment. So the application is built, the front end is built on the React, the back end is built on Spring Boot, and the database, the persistent storage is done using MySQL. So everything is a container over here. The React one is a container, server is a container, and your MySQL is another container. So everything is handled by Kubernetes over here. So for the client part, the React part, I did create 3 replicates of the client, everything, so that it properly handles, if something fails, the another client deployment might handle it. So keeping into that picture, that's how things are done in the production. So keeping into that picture, we have client, 3 types of client, 3 clients, sorry, and we have 3 servers and 1 MySQL. So over here, what does pod actually mean? It is the smallest unit of work or management resource within the Kubernetes. Any container you do, multiple containers or single container, which wants to share the storage, network, and the context, can be done within the pod. The second thing, we have the replica sets over here. Yes, the replica sets are used for managing the pod life cycle. Over here, you can schedule, scale, and delete your pod. So that's all you can do with the replicas, make multiple replicas of a single pod. Over here, we do have 3 replicas of a server, 1 replica of a MySQL, and 2 replicas of a client. Next is ingress. As I said, with the ingress, it's not actually a service, not actually a network service. It sits in the front of your multi services and act as a smart router or entry point in your cluster. So with the ingress, you are actually exposing your entire cluster service to the outside world. This can this can be entertained as your load balancer or routers. So yep. Next we have services. So within the services, there are majorly four types of services. We have cluster IP, node port, load balancer, and the external name. So cluster IP is usually set. It usually sets the IP address of a cluster. Along with that, we have node port. It statically sets the port address of your pod, whatever you're using. Then we have load balancer. Again, it's the legacy way. Ingress had replaced it, but it's a legacy way to expose your service externally using a cloud provider's load balancer. External name, it maps a service outside the cluster by providing a static internally referenced DNS name. Now coming to the storage part and the secrets part of it, Kubernetes. So here's a major challenge. You have deployed your MySQL container, but let's say you're making some changes. You made some changes in your database and now you're pushing it again. That way your database would be removed. The data within the database would be removed. So how to handle that? Well, we have something called persistent volume in Kubernetes. So it does the job for us. What it does, it represents the storage resource in the cluster, entire physical volume of the host machine that stores your persistent data. So how is it different from the persistent volume claim? Well, persistent volume claim represents the exclusive usage of a persistent volume by a particular pod. So let's say you have about 100 gigs of storage in your persistent volume in your cluster. So the persistent volume claim can claim up to 10 gigs, but it cannot take more than that. It cannot give a request for 110 gigs. So that is something you can do with persistent volume claims. There's also something called storage class. It's not being shown over here, but yes, over here we have storage class, correct. So within the storage class, a storage class provides a way for your administrator to describe the classes of your storage. What does that mean? It means like you can have multiple qualities, multiple storages based on the quality of service, backup policy, or arbitrary policy, which is usually determined by the cluster administrator. You can set that. So finally, before the demo, I'll just show you the secret part of it, the secrets and the configuration. Well, with the Kubernetes secrets, you can always store your sensitive information. So you need not to give that hard code your information maybe in an application property file or some other property file. So Kubernetes does the task for us. You can always set your secrets within the Kubernetes, be it a auth token or a SSH key. That things can be done using Kubernetes. So, yep, we'll be saying something called kubectl. So this was the particular part of the dashboard. You can always create a new pod using dashboard itself. All you have to do is pass your particular YAML or JSON content, and it will do the job for you. But I usually prefer the CLI way, the old way. So over here, let me run this command. The kubectl, you must be wondering, with kubectl is the command line interface for managing your operations for Kubernetes cluster. So what it does, it usually communicates with the Kubernetes API. So that's a plus point. I'll do a kubectl get all. This takes a second or two, but yes, over here we have, now I'm greeted with all the clients that are running the MySQL, the server, the one we just saw in our dashboard. We have services running. Within the service, it's a cluster IP. Kubernetes does have its own cluster IP, which can be reached using this particular IP address, and every cluster IP service, as we saw over here. Yep. These clusters, these deployments can be reached using, they are given a particular IP address which can be reached using ingress. Then we have deployments. As I said, deployments are containing the pods and their replicas over here. So let's see more about ingress. kubectl ingress. Well, we have an IP address over here. With this IP address, I can actually visit my own application. So I'll just show you the application which I made specifically for this session today. We have kubectl PVC. PVC stands for persistent volume claim. And over here, I've given 20 gigs to my MySQL, to the persistent storage within the minikube within the cluster, and this 20 gigs would be used by MySQL deployment. So yep, I'll just show you the application which we. So over here under the ingress, yes, this is the endpoint, and using this I can enter my application. So this is one such application, nothing fancy, but it gets the internet quotes, the famous quotes from the famous celebrities. Over here we have John Lennon. So over here you can check the new quotes from the internet, and if you like something, you can always bookmark it, and these can be seen. These bookmark are now set within your database, persisted in your database. So let's see a case where what if your MySQL database is gone? MySQL pod which was running is now stopped for some reason. So we have kubectl get, and I want to get the MySQL. Let me do a describe on this. Yep. Over here, we have every detail about the MySQL database, which I wrote in my YAML file. I'll show you what are the YAML files. So let's see what if it gets deleted. Delete. So here, uh, by incident, the MySQL deployment got deleted. So by default, the application should go down, but over here we see the application is still running fine. Everything works fine. So let me do a watch on kubectl get all. So what I did, I just deleted it. But as you can see the Kubernetes upped it by itself. It healed the component, it healed the deployment. So the age is 33 seconds. I didn't take much time. So by default, your application should go away, your data should go away, but no, Kubernetes did save us from that using PVC. So that's one healthy thing we saw using PVC. What about other deployments? Let me kill one of the deployment. You can always do deploy. Yep. Let me kill one of the pods, and be it a client pod. Okay, didn't kill. Server doesn't have the resource, so it didn't kill. Let me do one thing before killing it, or let me try killing the server. Would be disastrous in your simple application, but over here in Kubernetes, it will heal itself. It will not let you delete. There's some issue. Get all. Nope, it's not killing. Doesn't have a resource type server. Okay, Kubernetes. Okay, sorry, my bad. I'm not using delete command. So yep, delete, and little bit of syntax error. Deployment. kubectl get all. kubectl deployment, and okay, not the deployment, sorry, pods. And yes, the server deployment is now being deleted, but here's the impact of that. It's still running fine. Nothing has changed. And the Kubernetes has handled it by itself. As you can see, it did got deleted, but now it's running back again. So yeah, this is something, the fault tolerance within the Kubernetes. So what if you want to scale up the size? Currently I only have two clients running over here. What if I want to scale it to three? Scale, some traffic occurred and you want to scale up the thing. So let me do it for three, and I'll be increasing the deployment for client deployment. And now it's scaled. Let me check with watch command, and here you see the container is now being created. Your application would be running still fine. Nothing has changed. But over here, it is now ready to handle any extra request. So yep, that is something we can do with the Kubernetes. You don't getting any much of the traffic, you can always scale it down. Let's scale it back to say 2. It's scaled, and now you see the client deployment is now getting terminated. So simple things with the Kubernetes. These difficult things, takes hours to do. Within seconds, we did with the Kubernetes. So that is something you can do with the Kubernetes. Also, what if you want to make the changes? Well, with that, the Kubernetes does the job for us. We have various YAML files over here. And within the YAML files, let's say I want to check my client deployment. YAML file. And over here, just you have to change the version of your image, and that's it. The Kubernetes would fetch by itself. Or you can always give the command to do that using kubectl set. Yep, over here you can always get the latest image from your Docker Hub. So that is something you can do. I won't do this because building an image takes a ton of time, which is definitely we are short of. So yes, you can do that. So let me get back to the presentation. Over here, we did see the entire deployment and updating your apps with the Kubernetes. So yes, along with that, we also saw the workloads. Well, we know the workloads are what. With the workloads, you can set your workloads are the objects with which you can set the deployment rules for your pods. We have others as well, like stateful set, daemon set, jobs, cron jobs. So yeah, the simple application didn't need that, but with stateful set, you can always set the identity and store the data with the pod. With daemon set, you can always run a copy of pod on a node, which is best for collecting the logs and monitoring the node performance. With jobs, you don't have to run for an infinite time. The pods are running for an infinite time. If the task is done, it will do the task, and after the completion of task, the pod would be removed. Then we saw network. With network, we have service and ingress. That's how node communicate from node to node, and the containers communicate to other containers. We saw about the storage. Well, I didn't explain the volume part. Well, volume is something which is tied to the pod lifecycle. It's consumable by the one or more containers within the pod. We have persistent volume claim, and storage class. Then coming to the configuration and secrets, we have config map, which usually stores the key value pair for storing non-sensitive config option for apps and exposing into them. Coming to the secrets, well, you can do that with the base 64 encoded, so everything is safe. So how would you integrate your Kubernetes within the deployment pipeline? Well, with this, you can always say, like, you made some changes, your GitHub or any other version control system recognize those changes and ask the Jenkins on any other, say, continuous integration tool you are using. It will build the code, run the test cases, and perform additional checks. And along with that, it will build the image, the container image, and build that and deploy it to your Docker hub. Along with that, it will also notify your Kubernetes engine, be it in AWS or Google Cloud or Azure. It will tell, like, yes, I've built the image. Please kindly pull the image from the Docker hub. Kubernetes does that and deploys and manages the cluster. So things will be easy with the Kubernetes. So when it comes to building the large clusters, I'm pretty sure, none of us will be using such a large cluster. It's an overkill for any big application. Kubernetes supports cluster with up to 5,000 nodes. Along with that, it will support up to 150K total pods. Also, it can support up to 300K total containers, and it will have 100 pods per node. There's something you can always take care while deploying things, while using Kubernetes over Google Cloud and AWS. With Google Cloud Engine, with Google Kubernetes Engine, the size of master node adjusts automatically based on the size of your cluster. But with AWS doesn't allow this to us. If you are setting something, if you are setting in the startup time, you won't be able to change it after that. Now, some of the case studies, how Kubernetes helped the entire world. We all know of Adidas, multinational sportswear company. So now Adidas is running 100% of its e-commerce site on Kubernetes, and they were able to do that within just 6 months. So that's really less time when it compares to such a big company called Adidas. And with this, the load time of the e-commerce site was reduced by half. So win-win for Adidas. And now they are releasing their new application, their new builds within 3-4 times a day. That's really fast. Comparing to their earlier progress, it was only 4 to 6 within a week. So yep, uh, Adidas is running about 4,000 pods with 200 nodes and about 80,000 builds per month. So with this, they're running about 40% of its most critical and impactful system on their cloud native platform. So yes, Kubernetes did help Adidas a lot. Then we have Pinterest. Pinterest, we all know, you can share your information using images, GIFs, and videos on Pinterest. And Pinterest decided to move their microservices to Docker containers and chose Kubernetes as their orchestration system. So how did it help them? Well, with Kubernetes, they were able to build the processes, they build their application within the containers within no time. And definitely Kubernetes helped them within the orchestration part of it. They were able to reclaim about 80% of hardware capacity during peak hours. You can always upscale the hardware if you want to use within that Kubernetes in your peak hours, and you can always downscale the pods and nodes within the less peak hours. So it is quite evident, with these case studies, it's quite evident that containers and Kubernetes have an immense cost saving potential appreciated by loads of number of major companies. Thanks to the containerized application and container orchestration, you can expect about 2-digit cost saving and more productive utilization of your deployment, operation, and support team time. So yes, it is very well beneficial when it comes to the major companies. They're able to save ton of money and definitely help their teams to build a better application for their customer. Now all these things, the application which are developed, the containers, the servers and the clients, everything, the YAML file, everything is posted on the GitHub and Docker Hub. You can always check that. And that's it from today's session. So any doubts you have regarding Kubernetes, I totally welcome it. This was a just a brief introduction on Kubernetes, how it would help you guys a lot about deployment, building stuff. So that is something you can do with the Kubernetes.
Sir, we got a one question here.
Yes. How to stop Helm upgrade using Kubernetes? So, well, I haven't explored this much into the Helm. I only explored with the Docker part, but I can assure you that other than Docker, you can always use other containers as well, like Kata container, Sir.io, and also container D within your Kubernetes. But I haven't explored it. Maybe you can write it to me, and I'll explain you better. How to stop Helm upgrade using Kubernetes. I haven't done much on this Helm part of it. Only the Docker I have tried.
Okay, sir, someone has asked in general, how many nodes can Kubernetes handle in a cluster?
Well, it is 5,000. 5,000 nodes you can handle using Kubernetes. So that's a load of nodes, definitely.
Someone has asked, one can learn from scratch without previous experience.
Yes, for this, all you need to have a little bit of knowledge about Docker. And after you have done that, definitely you can jump to the Kubernetes part of it. I suggest, you can always visit EDX course of Kubernetes. It's really helpful. Along with that, there is multiple sites where you can check the Kubernetes. Kubernetes document, the official document is really helpful.
We have one more question, sir. How do I permanently delete a pod without having it restart again?
Yes, I can show you that. So I'll just share my screen back again. So one interesting fact, if I show my Docker containers right now, ps-a. So as you can see, we have tons of Dockers running over here. So if I delete a particular Docker container which is running, say I'm deleting the code server, and let me stop this particular part, Docker stop, Docker rm, and see everything, the pod should be deleted. Yes, the pod did deleted. It showed me an error, but it will come back again. So how to delete an entire deployment? Well, if you delete an entire deployment, it will delete the entire set containing your pods and replicas. Well, we can do that using docker git. Oh, sorry, not docker, kubectl. And kubectl delete deployment, and here I want to delete the server deployment. Server deployment is now deleted, and it will be see, everything is now being terminated. All the things would be gone. Your client and server is gone now. So that is something you can do using kubectl delete. You can delete the entire deployment. Hope this answered your question.
Nitish Kumar have asked, as a student, where can I start learning about Kubernetes and how to use it in our project?
Yes. So Nitish, what you can do is like I will always recommend get handy with Docker first. After Docker, you have done the Dockers. You have created your application as a microservice. So maybe let's say in this particular application, I did create 3 microservices. We had the client part, which used the React system. The second one, the server thing, was built on Spring Boot, and another, the persistent storage, was done on MySQL. So everything is now a container, and within this container, you can handle that using Kubernetes. So all you have to do is get these containers from the Docker Hub or whatever you are using, and deploy it. So yes, you can build multiple big multi clients, sorry, the microservices, and that could result in a big application. While learning to the Docker and Kubernetes, I would suggest one EDX is really good over Kubernetes. There's also one course on Udemy. You can also check that, along with yeah, their documentation is really good. So yes, the Kubernetes documentation and the Docker documentation, you can always check that for how to learn the Kubernetes and Docker.